Okay, welcome back to the Caribou Data Science Show. This is the first of two Midnight Madnesses this week. Tonight I'm going to look at a couple things. We can review the code for the live vaccine data on Kaggle. Then we're going to take a second look at the at the solar cycle data, the sunspot data, to try to see if we can determine when this current solar maximum is going to begin to decline. And third, time permitting, we're going to go out and we're going to jump on the old ChatGPT 0 Omni bandwagon. We're going to try to get ChatGPT Omni to first of all calculate the reciprocals for the first 10 digits, 1 through 10, and then write a Python code to calculate the reciprocal for any digit. Okay, so let's start over here. Here we are. So let's just review our code. In your apps, and I added a couple more plots, okay? Now what I want you to see here, the code is very basic, simple R code, okay? I'm using tidyverse, which includes ggplot2. I use janitor, and we're also going to use plotly to make some of the graphs more, well, not so much here, but we get to sunspots, we're going to use plotly to make the apps interactive. Okay, but so let's start here, and you can see it says over the last 50 years, that says vaccines have saved 150 million children over the last 50 years. I'm not sure how we actually knew that, but anyway. So again, the code is very simple. You can see up here, I'm calling three libraries: tidyverse, which includes ggplot2, janitor to clean up column names, stuff like that, and plotly if we want to do some interactive plots. We load that. Then we come over here and get the data over here. And we use the clean names function from janitor, okay? Let's come back up here, load our libraries. Let's load our data. And here's the full data set. We're only interested in diphtheria through polio and then tuberculosis and yellow fever. That's the full. So we come down here, we use a select function to select a column. Now the colon means start with this column and end with this column. So we're going from diphtheria to polio. Okay, diphtheria to polio, tuberculosis, yellow fever. Then there's a total. I'm not quite sure what the totals actually represent, okay? So that was simple enough. This is a much smaller data set to work with, and here is the what this looks like, okay? Now I want to point out one thing. This is all the rows there is in this data. This is for as of the year 2023, I think, when these numbers are compiled, and it's all you got is basically the continents, and that's all the data there is. There's one row for each continent. Then we're going to calculate the quantile for the total column. Okay, so we got a nice big spread here. You could say 72.12345. 72 times 10 to the 5th maybe, or something like that. Here's the 25th quantile, the median value, and the 75th quantile. And the interquantile, I don't know why that's there. How do I get rid of that? There we go, okay. So now I'll calculate the interquantile range, which as you can see is the 75th quantile minus the 20th quantile for the total column. And as you can see, that's still a pretty big, that's still a pretty doggone big spread there, okay? Now we're going to take a look at the diphtheria. So what we do, we start out by getting more interested in this number right here. This is the interquartile range, okay? So then we start out with simply plotting the diphtheria data. We're saying the range description, and so we're sorting by the order of the entity. Actually, what GT plot 2, so we're saying descending, arrange, sort descend diphtheria. Diphtheria, of course, is the number for the number of lives saved. So we're sorting by the number of lives, descending by the lives saved. We do a mutate on FCT reorder. Now there's actually a way to do this with inside of the aesthetic function, but I just don't remember what it is, because this code here was actually written by GPT4ALL, okay? Then we do a quick plot. Add some descriptive labels there. We eliminate the x-axis text, x-axis text, and x-axis title. Let's just take a look here. And that's what that looks like. You can see you can see by the world is saved over. Well, we could know up here, don't we? Now there is a way to, if I can only remember how to do it. There's a package called Scales. Oh, I'm going to hate myself for this. Okay. What is it? There is a let's do this. Let's give ChatGPT4ALL a chance to help us with this code here, okay? What is it? Is it geom scales or something like that, or is it scales x continuous? I can't remember. Now, let's be honest about this. It's nice that this is that's not right. As you can see, this is not ChatGPT 4 yet. Okay, it's a simple. I would say it's not even ChatGPT 3.5, honestly. How do you do that? Scales continuous. It's been so long since I've actually done this, I can't actually remember what it is. It's something continuous. Is it scales? Is it continuous x-axis? But you can see, obviously, if we throw out the world numbers, you can see that Africa, and this is going to be consistent. The biggest progress in terms of child lives saved is consistently in the continent of Africa. Okay, so this is Africa. You can see Americas, which is down here. But a lot of these diseases were eradicated in America, in the U.S. for you know, way back into the 20th century and so forth. Okay. Now it's live saved by continent and disease, and this is kind of fun here. Okay. What we do here, I'm taking this, the data minus the total. I'm using a pivot longer function. Okay. The columns are diphtheria to yellow fever, and the names are to diseases, and the values are live saved. And that's what you see here. Now, if we were to print this all out, you'd see all these diseases here. Then the next line would be say you know, Europe or something like that. So you have for each continent, for each disease, you have one row live saved. Okay. So now we're coming down here. So there's the scales library. Good. Okay. And now we're saying, yeah, of course, the exclamation point means no. So it says, do not remove the rows that contain the entity that contains the word world. Then it's just simply a plot. Diseases, why? The disease, right? And the live saves. Then the color or the fill. Let's see if we get back over here now. Now this is interesting. So they're formatting the label. Interesting. Okay. Let's come back up here. And what they're saying is, if that actually works, that's actually pretty doggone sweet. You know what I mean? Let's see if it works. Interesting. So they're leaving off they're putting a comma Okay, so they're not putting it there. See, the trouble with this is you can't really copy it, see. Because that doesn't say diphtheria. let's do this. Let's make another comma. Let's make another comma. Let's copy this. And you're saying replace X. I don't think that's right. So they're saying do this. Yeah. Okay. Well, as much as I hate to leave this behind, let's come over here. Okay. No, I'm still on 4. We'll save, that's exactly what we were looking for. Very good. So we can come back over here. We could just delete this cell. Okay? There's nothing wrong with my connection, okay? Okay, so you can see Africa, over 200,000 lives have been changed. The number of deaths reduced to the last 50 years for diphtheria in Africa is over 200,000 for children, okay? And then I come down here, we're going to come over here again, right? And again, so this is the lives saved by continent. And this is a disease. You can see again, measles was the biggest amount of lives saved, okay? You got diphtheria, but diphtheria was a very small thing, less than. Well, we're talking for measles, we're talking over probably 100 million people's lives saved, okay? So there's still nothing tricky there, okay? We took the pivot long data and we simply did a straight plot with the fill, okay? Now we get a little more trickier. Now we're going to add in what's called, that's what it's called. Facet wrap. So in this case, we're going to create a plot for each continent, okay, and then the disease on that, and then we're going to add a comma to it, okay? Okay, so now we got, for each continent, okay, we got the diseases and the lives saved. Again, you can see Africa, measles has been the biggest reduction, the greatest number of lives saved. Worldwide, as you can see, is from measles, and second, or not very well second, is tuberculosis. Okay. Now we reverse it. Okay, now reverse it. We're going to create a plot again. This time, now we're going to say, you know, create a new plot for each of the diseases. Now, what does this free y say? What free y does, it frees up the y-axis, so each plot has its own range of values. So you can see here, this goes from 5,000 from 0 to 200,000. But let's just run this thing over here, and we added a commas function, so this is the free y. Hang on a second here. Well, we can't really do that, can we? Okay. So now you can see the range of values from 0 to 200,000 lives over here. Again, so this is a bar chart with a separate plot for each disease and a separate column for each continent. So you can still see, well, this is interesting. So this is Africa. The blue is Southeast Asia. So this is kind of interesting. Hepatitis B in the Western Pacific. But then what you can see here is it gives us separate y-axis values for each of the plots. So because this goes from 0 to 200,000, this one goes from 0 to 30 million. You can still see there were a lot of lives saved from measles. Is still the biggest one. Okay, but what's interesting is 200,000 in the Western Pacific. Over 200,000 children's lives have been saved from hepatitis B. And again, in the South Pacific, over almost 500,000 lives have been saved from polio. Now, yellow fever is kind of the odd one. What color is that? I think it must be Africa. Okay, so that's kind of where we are right now. What I want to emphasize is I didn't do any data cleaning. I didn't do any type of data analysis, numeric data analysis. I didn't do any tricky plots. I used 3 packages, right? Tidyverse, Janitor, Plotly. I haven't actually used Plotly here, and then now the Scales package. And this is the beginning of EDA. This is the beginning of exploratory data analysis. Okay. I do wonder how you make those plots bigger. Let's try something different. So that actually worked. I'm not sure this will actually work, but we'll see. Yeah. Well, if you're out there and you know how to change the plots like this over here, I mean, you would think you could do it somewhere within the theme or somewhere within the ggplot command itself. Okay, so where do we go from here? Let's move on to the second part here now. Again, I want to emphasize all this code, like this theme stuff and the axis stuff. That all came from GPT4ALL. Now, as you saw, GPT4ALL on my system is pretty slow. Okay, and it's not nearly as good as, and it's not as good. It didn't understand the scale continuous function as part of the scale package. Okay. So the most lives saved have been in the measles, followed by, interesting enough, tuberculosis. Africa. Yeah, tuberculosis. More lives have been saved with tuberculosis than any other. The disparity between even tuberculosis and the rest of the disease is pretty significant. Okay, it's pretty significant. Again, this is excluding the world. Do we have the world up here? Let's do a plot of tuberculosis. Let's just come down here. I'll give you a bonus plot, okay? Now, there was a time, I think back in the 20th century, when tuberculosis was a big problem in the U.S., okay? You had, and one of the things that was determined to help was a warm, dry climate, a warm, dry climate. For instance, in Arizona. So sanitariums went up in Arizona, and the people would go to these places to get the warm, dry air, and try to recover. And apparently, it may have provided a short-term relief, I think, but I'm not sure if it permanently cured a person of tuberculosis. But let's see what happens here, okay? Of course, again, these are all children. I'm not sure. My guess is that a child, it probably tells us someplace, right? But my guess is that sometimes a child is considered anyone under the age of 5 or younger, okay? So let's come back up here to the top up here to our is that it? That looks about right. That's interesting. For some reason, just double printing the columns. But it didn't do it here. So let's see how this works. So worldwide, boy, maybe over 10 to 12 million children's lives have been saved by a tuberculosis vaccine. Okay. So let's do a second plot without the world. So now what you can see here, consistently the biggest strides have been made in reducing child deaths from disease is Africa. Because over
Okay, let's put ChatGPT. What we really want here, we really want these numbers to be at the top, right, of each column, right? Okay. Let's come down here. Let's add a new. Oh, very nice indeed. Very nice indeed. Okay, so that's. Well, I could probably do the same thing. I could probably do the same thing right here. Just off the top of my head, okay? Except change it. Let's try this. Let's take this. Okay. Let's change this to Y. This is a wild stab in the dark, but let's just see what happens. So let's come back up here. Let's delete this one. Let's leave this like this. I hate to say it, but daggone it, GPT4 is remember, this is just 4, right? This is just 4. So the obvious question: when you go, if you're writing code, when do you go from 4 to 4 Omni? Okay. So you can see here now. Again, this is tuberculosis deaths. America's 231,000 was saved in the last 50 years. Okay. Okay. For this, okay, new plot. All right. Okay. Now, supposedly, 4 Omni should be to go out to the internet. Let's come back over to Google. Now this is surprising. I must say that this is a bit of a surprise. I had no idea that 600 people died from tuberculosis in 2021. That's interesting. I thought tuberculosis was pretty well eradicated. But you see, it began. Okay, this is one of those things. Can we somehow grab this data somehow? You know what? This is another cliffhanger session. This is the end of tonight's session. I'll continue to try to grab this data out there for the tuberculosis deaths in America, cases and deaths in America. And we'll do a follow-up on that next Sunday, or we'll do a follow-up on this Thursday night. We have a special session, Midnight Madness session this Thursday to deal with the with the tuberculosis cases and deaths by year in the U.S. Because I'm shocked. I'm surprised that people in the U.S. are still dying from tuberculosis. Okay. So anyway, that does bring this session to a close. Hope you saw once again, one, how easy it is to do EDA with R, and you can do the same thing. It'll be just as easy to do the same thing with Python. Matter of fact, I may even do that, okay? And the other point is this. The difference between GPT4ALL and ChatGPT4 or Omni is the difference is still of night and day, okay? Thanks so much for your time. Of course, as always, hey, don't forget to click that like button for me, okay? And share the channel with the video with one of your friends this week, all right?